Refraction of light through lenses. A lens is any transparent material with two faces, of which at least one is curved. It causes a beam of light passing through it to either converge or diverge. There are two kinds of lenses. So the two kinds of lenses, one of them actually converges light rays, while the other one diverges light ray. Now, let us discuss about the two types of lenses. The first one is the converging or convex lens. It makes a parallel beam of light to converge to a point called the principal focus F. Such lenses are thicker at the center than at the edges. So you can take a look at the image there. You can see for yourself a convex lens. The centers are actually thicker than the edges. So you can see parallel rays entering the mirror, incident on the lens rather, converge at a point F, which is called the focal point. The distance between the center of the mirror and F is called the focal length. 2. Diverging or the concave lens. It makes a parallel beam of light to appear to diverge from a point called the focal point. Such lenses are thinner at the center than at the edges. So you look at the diagram, incident rays which are parallel to the principal axis will appear to come from the focus F from the other side. Let us now discuss the lens parameter. The following important parameters of a lens are discussed below. 1. The optical center C of a lens is the point through which rays of light pass without being deviated by the lens. So when light ray passes through the optical center, they will pass through it without being refracted. 2. Principal axis. The line which passes through the optical center of the lens and joining the centers of curvature of the surface of the lens is called the principal axis of the lens. 3. The principal focus of a lens is divided into two parts, which are that of a convex lens and that of a diverging lens or concave lens. So let us take a look at the principal focus F of a converging or convex lens. It is the point to which all rays which are parallel and close to the principal axis will converge after the rays has been refracted through the lens. So for the principal focus of a converging lens, the rays actually converge at that point F, which is called the principal focus. The principal focus of a diverging or a concave lens is the point from which all rays which are close and parallel to the principal axis will appear to diverge after the rays have been refracted through the lens. So for a diverging lens, the rays do not actually converge, they actually appear to diverge. They appear to be coming from the principal focus. A lens has two principal foci, since light may pass through a lens in either direction. So what that means is that at the front of the lens, you have a principal focus there, and behind the lens too, you also have a principal focus there. Light rays can travel through the lens in both directions. Now, let us consider how to locate images on lenses. There are three classes of rays that can be used to obtain the position and nature of the images formed by lenses. They are: 1. A ray from the object parallel to the principal axis will refract from the lens and pass through the principal focus F. So let's take a look at that. This is a lens with the optical center C. So if I draw a ray which is parallel to the principal axis, that is from 2F to 2F prime, the ray will be refracted through F. So I indicate my directions. So the ray, which is represented by the green ray, will be refracted through F prime, which is the principal focus on the other side. 2. A ray from the object passing through the optical center C of the lens will pass through it undeviated, meaning that it will not be refracted. So that is C. So let me get my incident ray represented by the red line. So a ray that passes through it will pass it without being what? Refracted or what? Deviated. 3. A ray from the object through the principal focus F emerges parallel to the principal axis after reflection. So again, let me get a ray that passes through F. When the ray passes through F and strikes the lens, it will be refracted parallel to the principal axis. So let me indicate my direction. That's the incident ray. So the refracted ray is represented by the green line. So you see that it is refracted parallel to the principal axis, that is from 2F to 2F prime. Again, I can also determine that with another ray passing through from the downside to the upper side. Okay, this, I didn't get this right. Let me redraw that again. So a ray passing through F will also refract. So let me indicate my direction. Will also be refracted parallel to the principal axis from the other side. So I must indicate the direction of the rays refracted to indicate that they have refracted by putting my arrows. Next, so how do we locate the position of the image? The intersection of any two of these rays correspond to the position of the top of the image that is formed. So if you combine any two of those, you get the position of the image that is formed. So let us look at the position and nature of images formed by converging lens from different object positions. So let's look at the first part. 1. A ray, parallel ray that are coming from infinity will strike the mirror and the image will be formed at F prime. So these rays are parallel rays coming from a distance object. So from infinity means that the rays are actually coming from a very far distance object. So all rays that are coming from that distant object will converge or will meet and intercept beneath F prime. So that is where the image will be formed. So let me take another ray which is parallel to the first one, passing through C. Now you see they intercept at immediately below F. So that point of intersection is where the image is what? Formed. Now this ray that is drawn, the red ray, is drawn at an angle. So it will not be refracted through F, but it will refract in such a way that the rays will intercept at F, below F. So you can see the nature of the image. So I'll draw my image from F down to the point with the arrows indicating that the image is inverted. So the nature of the image formed is that a real, diminished, and inverted image is formed. Object placed close to the lens but beyond 2F. So let me draw my object beyond 2F, indicate the direction with arrows. Then I'll draw a ray which is parallel to the principal axis. A ray that is parallel to the principal axis is going to be refracted through F prime. Indicate your direction. So the ray refracts through F prime. I will indicate my direction. So I need another ray to show where the image, the rays will intersect, where the image will be formed. So I need another ray to be drawn to intersect with this. So a ray that is drawn through C intercept between f prime and 2f prime. So I must indicate my direction. Now you can see where the rays intersect. So I'll draw a ray from the principal axis down to the point where they intersect. So I'll indicate my arrow with my arrows to show that the image is inverted. So let's look at the nature of the image. A real, diminished, and inverted image is formed between f prime and 2f prime. Object at 2f. So I'll draw my object at 2f, indicate that it is upright with the arrows pointing upwards. I'll draw a ray parallel to the principal, a ray through the center of curvature. A ray which passes through the center of curvature passes through it undeviated. So I have to indicate the direction of the ray with arrows. Next, I'll draw a ray parallel to the principal axis. Again, I will indicate with arrows the direction to show that it is incident ray. The ray will be deviated or refracted through f prime. Now you see that the rays will intercept immediately below 2f prime. So I'll draw my image through the point of intersection to the principal axis. This represents the image. So next I have to indicate that the image is inverted by drawing arrows that are pointing downward. So you can see that the size of the object is the same as the size of the image. So the nature of the object formed, image formed, is that it is ray inverted with the same size as the object that is formed, and it is formed at 2f prime. Object placed between 2f and f. So I can place the object anywhere between 2f and f. So I indicate by drawing my object upright with the arrows pointing upward. Then I will draw a ray passing through C, and the ray will pass through it undeviated. I'll indicate my direction. Then again I will draw a ray parallel to the principal axis, indicate the direction of the ray, showing that it is an incident ray with the arrows. The ray will be refracted or deviated through f prime rather, and the point of intersection of the two rays is beyond 2f prime. So I indicate with my direction again. Then I will draw a vertical line from the point of intersection to the principal axis and indicate the direction that it is inverted by placing arrows downward. So this is the image form. The image is real, magnified, and inverted, and it is formed beyond 2f prime. Next, object at f. The object is placed at f, so I've drawn my object at f upright, indicate with arrows that it is upright, the arrows pointing upward. Then I will draw a ray passing through the principal, the center of the optical center, then indicate with direction, arrow. I'll draw another ray parallel to the principal axis, indicate the direction. The ray will be refracted or deviated through f prime. Now notice that the rays that are formed will never intercept. They can only intercept at infinity. So I will indicate my arrows. So two sets of parallel rays are formed that intersect at infinity. So we say that the image is formed at infinity. It is real, it is magnified, and also inverted. 6. Object placed between F and C, that is the principal focus and the optical center. So I can place it anywhere between them. I draw an upright image, indicate with direction that the object is upright. Then I will draw a ray through parallel to the principal axis, indicate with directions or with arrows the direction. The ray will be deviated through F prime. Now I will extend this ray upward because the rays will not actually intercept or converge there. Rather, the ray will appear as if they are coming from F prime. So they appear as if they are coming from F prime to back of the mirror to where the rays are coming from. Now I'm going to break the lines because the rays are not real rays, but they are imaginary rays. Next, I will draw a ray through the optical center C. So a ray that passes through that will pass it undeviated. So I have to extend the ray downward and upward, indicate my direction, and the point of intersection between them, I will note it and draw my rays through the point of intersection, my object image through the point of intersection. Indicate my arrows Now the rays, I'll break the rays too because they are not real but imaginary. Next, I'll draw an image. Okay, I extend this because there is no space for me to draw the image, so I extend the principal axis backward so that I can draw my image from the point of intersection down to it, to the principal axis. So I'll indicate with arrow that the image is upright but virtual. So I have to break the lines to show that it is virtual. So the nature of the image form is that the image is magnified, erect, and virtual, and it is formed on the same side as the object. You can see that the image is bigger than the object.
Now let us look at the position and nature of the image formed by a diverging lens. So if I draw an object in front of the diverging lens at any point, I can locate the images by drawing parallel rays to the principal axis and through the center of curvature. So here I have a ray parallel to the principal axis. When it strikes the surface of the lens, the rays will appear to come from the principal focus, which is on the same side as the object. So you can see that there's a difference between the image formed here and the one formed by a convex lens, because the image formed or the rays of diagram are converged on the other side. It passes through the principal focus on the other side of the lens. Here I'm breaking the rays because the rays appears to travel from F to that point. They are not real. So here I will take another ray and draw through the center of curvature C. So when I draw the ray through the center of curvature, you know, any ray that passes through the center of curvature or the optical center of the lens will pass it undeviated. So the images will be formed at the point where the two rays intersect in front of the lens. So as you can see, the image is diminished, it is virtual. So I'm going to break the lines, and it is smaller than the object. It is formed between the object and the lens. So for a converging or diverging lens rather, the image is always erect, diminished, virtual, and formed between the object and the lens.